Dear students, today we start the new concept under electric charge and electric field topic. The topic is electric field lines or electric lines of force. First we understand what is the meaning of electric field line or electric lines of force. Electric field line is an imaginary path along which a unit positive charge tends to move. That is nothing but it is the imaginary line drawn around a charge to indicate the direction of electric field. I repeat, it is the imaginary line drawn around the charge to indicate the direction of electric field. The diagram should be like this. If we take a positive charge and around a positive charge we indicate the line to indicate the direction of electric field. This line is just imaginary to indicate the direction of electric field. Even in case of negative charge also we consider number of lines. It is just to indicate the direction of electric field. Now under electric field lines or electric lines of force we can learn the properties or characteristic of electric field line. Now this one is one of the important concept for annual exam. They're going to ask this question mainly for 3 marks. Now there are several properties or characteristic in that. First important basic property or characteristic is the electric field line originate from positive charge. The diagram is like this. If we take a positive charge, electric field lines originate from positive charge. That means from positive charge the electric field lines will come out. That indicates that positive charge providing diverging field. And terminate on a negative charge. Second diagram here. The negative charge around that we consider electric field line. Here electric field lines are terminating on negative charge is nothing but the negative charge will producing converging field. And the second important property is lines of force never intersect. The reason is start from positive ends at negative. It is having unique property, that's why lines of force never intersect is one of the important characteristic of electric field line. Lines of force never forms a loop because it starts from positive, ends at negative. That's why it never form a loop is one of the third characteristic of electric field line. And fourth characteristic of electric field line, they are normal to the surface of a charged conductor. If you take any one charged conductor, if this one is a surface, for this surface, if the surface is positive, electric field lines are acting outward. Surface is negative, electric field lines are acting inward. For this surface always electric field lines acting normally. That's why they are normal to the surface of charged conductor. Next important characteristic, they never enter a conductor. The reason is we already learned basic characteristic of charge. All the charges are located on the surface of a conductor. Inside a conductor net charge is equal to 0. So electric field inside a conductor is also 0. That's why they never enter inside a conductor or they never enter a conductor. It is one of the characteristic. Now last characteristic, more crowded electric field lines where electric field is stronger. If we consider any charge, it containing large number of electric field lines, that indicates that crowded field lines. The crowded field lines gives idea that electric field is stronger or charge strength is more, and less crowded electric field line indicates that electric field is weaker. Now these are the several characteristic or properties of electric field lines. I repeat this characteristic once again. The electric field lines are the one they originate from positive charge and terminate on negative charge. It should be like this. Positive charge providing diverging field, negative charge will provide converging field. Lines of force never intersect because it got a unique characteristic. Lines of force never form a loop because starting from positive ends on negative. They are normal to the surface of a charged conductor. They are never enter a conductor. More crowded electric field lines where electric field is stronger. Reverse part, the less crowded electric field line where electric field is weaker. These are the major characteristic of electric field lines, and this part is very much important for exam. Now next important thing is diagrammatic or a pictorial representation of electric field line. This part is also important for exam, mainly for 2 marks. There are 4 different cases. We'll discuss all the cases one by one. First case is if I take Q is greater than 0. If I take Q is greater than 0, that indicates that nature of charge is positive. I already told positive charge where electric field lines are coming out, it is nothing but it providing outward direction. That's why around a positive charge, lines of force outward, it is a representation of positive charge. In case of second part, Q is less than 0. That clearly indicates that nature of charge is negative. For a negative charge, electric field line will terminate. That's why around a negative charge, we consider large number of line, all the lines, direction acting towards the charge. It is a representation of electric field lines. It may be a diagrammatic or pictorial representation in case of negative charge. And third important thing is two equal charges. That means if we take plus plus or if we take minus minus, when you want to multiply Q1 and Q2, it is plus plus, it is greater than 0, or if it is minus minus, minus into minus, it becomes positive only, greater than 0. That's why condition is Q1 into Q2 greater than 0. Both are two equal charges. That's why if you consider this diagram, there are two set of diagram. If I take a plus plus, both will repel each other. The diagrammatic representation is like this. If I consider minus minus, both are repel each other. Diagrammatic representation is like this. Now these two are the representation for plus plus and minus minus. Both indicates two equal charges. Next, fourth important thing is electric dipole. In a last video, we already learned what is the meaning of dipole. Electric dipole are nothing but two equal charges, but they are opposite in nature, separated by very small distance. Now that provide a condition like this, Q1 into Q2 less than 0. Reason is plus into minus, answer is minus, automatically net result is negative nature. That's why when you go to consider this diagram, positive charge and negative charge, both plus and minus, they will attract each other. Diagrammatic or pictorial representation of electric field line for electric dipole or plus minus charge is indicated or as shown in this diagram. Now next important part, to further continuation of this concept, the new concept is called electric flux. It is denoted by letter pi, capital Pi. Electric flux is nothing but the number of electric field lines passing normally through a given surface. It is number of electric field lines passing normal through a given surface. If we consider this one is a one surface, here large number of positive charges are present, automatically electric field lines are acting normally outward. If it is a negative surface, large number of charges are present on the surface, negative charge, electric field line is acting inward. And this indicates that the major concept called electric flux, the number of electric field line passing normal through a given surface. If I consider one surface like this one is a representation of one surface. In that surface, I consider small surface area, delta S. That surface area always acting normally outward. If it is area is smaller, it is indicated as vector and it is acting normally outward. Here delta S represent the area vector acting normally outward. For this surface, we apply uniform electric field is denoted as E, and angle between electric field and area vector delta S is theta. By using this electric field, we can also electric flux we represented as pi is equal to E vector dot delta S vector. It is a scalar product because electric flux is the scalar quantity. That's why flux pi is equal to E vector dot delta S vector, where E and delta S both are vector multiplication by using scalar product. And by using this, we got a general equation. Flux is equal to magnitude of E vector into magnitude of delta S vector into cos theta. Here theta is the angle between E vector and delta S vector. Depending on the value of theta, we decide whether the flux may be maximum or flux may be minimum. If pi is nothing but electric flux is maximum, the angle between E and delta S is equal to 0 degree. If pi or electric flux is minimum, the angle between E and delta S is equal to 90 degree. These two value of theta indicates that whether the flux is maximum or minimum. In case of any surface, if we take here, area vector is acting outward like this, and again in case of this, electric field applied parallel to that. In other words, electric field and delta S both are acting outward, the angle between these two is equal to 0. And again, if I take any one surface, here electric field is acting like this, area vector is acting perpendicular to that, angle between electric field and area vector is equal to 90 degree, automatically flux becomes minimum depending on angle theta. Now these are the clear explanation for electric flux. Again I repeat, keep the point clearly in your mind. Electric flux is nothing but number of electric field lines passing normally through a given surface. General expression for electric flux in terms of vector, pi is equal to E vector dot delta S vector, and in general pi is equal to modulus of E vector modulus of delta S vector into cos theta, where theta is the angle between electric field and area vector delta S.